Hi everyone, and welcome to part 4 of activity 13. Today we are going to talk about slant asymptotes. Our slant asymptotes are similar to our horizontal asymptotes in that they are kind of what the end behavior of our graph follows along, but these are going to be the equation of a line, aka a slant, as opposed to just a horizontal line. Like y equals just a constant number. This time it'll be the equation of a line. So in order to find the equation of the slant asymptotes, these are going to occur when the degree of the numerator is exactly 1 greater than the degree of the denominator. And oftentimes you are using either the synthetic division to find the equation of the slant, or you are using the process of long division. So for instance, on the first one, we have our function, our rational written 3x squared minus 2x plus 1 all over x minus 1. And basically what's happening is if we can get this rewritten in a slightly different format so that we can see the slant or the horizontal asymptote for that matter isolated, that will help us actually see not what the equation would be that it's following along versus just this original form. So what we do to start is we take that denominator value, x minus 1, and we set it equal to 0 so that we see where that vertical asymptote is at. So in this case, it is at x equals 1. And then we take the leading coefficients, 3, -2, and 1, bring down the first term, multiply, add down, multiply, add down. And what's basically happening is we are taking this original function, this original rational as a whole, and rewriting it so that it's in the form y equals 3x plus 1, and then we have that remainder value of 2 over that denominator piece, x minus 1. So what's happening is this actually allows us to see the equation of our slant asymptote, which in this case is going to be y equals 3x plus 1 for the equation of our slant. And we can double check this if we look at these two, if we compare these two graphs. Again, we have this original function y equals 3x to the second power minus 2x plus 1, and then all divided by x minus 1. And again, we are just rewriting this when we rewrite this as y equals 3x plus 1 plus 2 divided by x minus 1. This is the exact same line, right? When we look at this, whether it's the blue or the red, it's the exact same line. It's just written slightly differently. What the second one really allows us to do, though, is see the equation of the line that we are following along, in this case, that slant of 3x plus 1. Now, we are also able to use the process of long division to find this. So again, dividing by that denominator of x minus 1. In order to do that, to make 3x into 3x squared, we would multiply it by a 3x. So this would become 3x squared, and then 3x times -1 is -3x. And then you have to distribute a negative through so that this would add down to become 0. -2x plus 3 is positive 1x. Bring down that 1. And then to get -1 to be 1x, we would multiply it by 1. So 1 times x is 1x. 1 times -1 is -1. Again, flip the signs and add down. We get that 0 and then plus 2. So we see that remainder like we had over here. And again, it's another way of rewriting this. We have the y equals 3x plus 1, and then that remainder down here of 2, again, would also be able to show us how to rewrite it into this form. Now, long division is useful if you have more than just an x squared and an x. Synthetic division, though, if we're just doing x squared and an x, then we should be able to just use synthetic, which is a little bit quicker. Okay, so again, kind of continuing on with this equation form to see these, if we are being given the equation, we know that the asymptotes are going to involve, in this case, a slant one at y equals 2x plus 1, And then also, based on this denominator, a vertical asymptote at x equals 0. And if we're in charge of writing the equation, this one, notice they gave us negative 3x minus 2 as the equation of the slant. And then we have x equals 1, aka the factored form would be x minus 1 as our vertical asymptote in the denominator. Note that this number that's up top here, it doesn't matter what value you put for this constant. A is just a constant. So you could make it 7, you could make it 99, you could make it 1. All right, that number can vary. Like I said, it could be 7, it could be 2, it could be 1. All right, this number is not going to matter as much as the placement of negative 3x minus 2 and then x minus 1. Now, in example 3 here, we are asking us to find the slant asymptote of the function. So again, step 1 is still kind of involving finding that vertical asymptote. In this case, we have one at negative 3. And if we use synthetic division on this one, notice our top pieces, we have 1x squared, 0x, and a 4. And again, where we're getting these numbers is we don't have a term for x in the original, but we still need that placeholder in the equation. So bring down the 1, multiply it by that vertical asymptote value of negative 3, add down. And again, it's not saying necessarily that this remainder piece isn't important, but if our overall goal is to find the equation of the slant asymptote, really what we care about are just these first two terms, because this remainder, this constant value, again, isn't so important to us for the equation of our slant asymptote, which in this case is just y equals x minus 3. All right, another one to try here, again, using our synthetic division. Again, we always want to start with that vertical asymptote. In this case, it's at negative 2. And we have 1, 4, and 5 as the values of our coefficients for the synthetic. Bring down the first term, add down. And then again, not saying that this isn't as important, but this remainder piece is not going to be a part of the slant asymptote. The slant will be made up of these first two pieces, y equals 1x plus 2. Finally, there is an example for you to try, like this one. For number 5, find the equation of your slant. And then our last example with the slant here and finding is a slightly different one because we have, note here, a coefficient other than 1 on this. So all of our other examples, we had 1x, 1x, 1x. This time we have a coefficient here of negative 2. Now we're going to start off by finding our vertical asymptote the exact same way that we have been, right? Set that denominator piece equal to 0. We get negative 2x equals negative 9. Divide by the two negatives, we get 9/2 or 4.5, if you like that, using the decimal a little bit better. And then the main thing that's going to change when we have this leading coefficient of negative 2, instead of just using 8, negative 44, and positive 41, we need to divide all of those by that leading coefficient because that a value is not just 1, it's negative 2. So really what we're going to be plugging in for this piece here is negative 4, positive 22, and then negative 20.5. And as we synthetically divide this time, multiply 4.5 times negative 4 is negative 18. Add down, multiply, and then add down again. The remainder piece here is not so important for finding the slant. The slant this time is going to be negative 4x plus 4, again using these first two pieces of our synthetic division. All right, now we have one final example here then. And this time is going to be looking at the equation or the sketch of a graph given a slant. So certain things are going to be the exact same as before, right? If we are dividing by 0, if we plug in 0 for x and we're dividing by 0, our y-intercept this time is not going to exist because we can't have division by 0. This time we know there's going to be a slant asymptote because the degree of the numerator is bigger than the degree of the denominator by exactly 1 degree. So we know there's no horizontal asymptote, but there will be a slant. Now this time, our slant asymptote, we can find it a couple of different ways. Option 1 is, again, using some synthetic division because we know x equals 0 is our vertical asymptote. We have 1x squared, 0x minus 9. Bring down the 1 and multiply. What we're going to notice here is that our slant is at y equals 1x plus 0 or y equals x. And then we don't have any holes this time because nothing canceled out. If we factor the numerator and denominator to see that, we have a difference of squares. And again, nothing's canceling out, so no holes. We will, however, have 2 zeros, one at negative 3, 0, one at positive 3, 0, those x-intercepts. So one here, and then again we have that vertical asymptote through 0, and we have horizontal asymptote, slant asymptote through the line y equals x. So there's kind of that horizontal asymptote. And again, it might even be easier if we just dash that so we know what that is. All right, now this time, because of the nature of our slant, okay, again, it's going to pass through our x-intercept, but then it's going to kind of follow along these different asymptotes, this vertical one, and then down along this horizontal one. So we see kind of that curved nature of that following along. And again, we can plug in some test points if we're really not sure. For instance, if I want to plug in -1, for instance, -1 squared minus 9 all over -1, well, we would have -8 divided by -1. So -1 comma positive 8 would be our answer there. And again, we can kind of double check this just for the sake of getting used to starting to sketch these. If we sketch this graph here, we can kind of see, again, that curved nature, and it's all kind of going along our line of y equals x. All right, thanks everyone for watching. We'll work more with these in class.